Hello everyone, welcome to the session. In this session I am going to discuss about the importance of X-ray diffraction characterization, especially for the materials point of view. So this part is there in your 5th unit related to the nanomaterials characterization as part of SEM, TEM and XRD. So in this video I am going to discuss about that particular part, X-ray diffraction. So if you have any tension related to the X-ray diffraction technique, you just sit, relax and listen the things what I am going to discuss. Here coming to the XRD point of view, examiner may ask you the question like explain the in detail relate to the X-ray diffraction or explain the importance of X-ray diffraction characterization in characterizing the materials. So coming to this particular topic point of view, XRD is the short abbreviation related to the X-ray diffraction. It is everyone know. And how it works, for what purpose we are using the X-ray diffraction. So coming to this particular part, X-ray diffraction works based on the principle of Bragg's law, that is 2d sin theta equals to n into lambda. Here d is the interplanar spacing and theta is the glancing angle, lambda is the wavelength of the source. So this is the basic principle involved in getting the X-ray diffraction for a particular material. So coming to the which materials we can get the diffraction. So obviously materials point of view we have different kinds like crystalline and amorphous is the two basic classification based on the arrangement of the atoms. Crystalline is nothing but regular arrangement of atoms. Once it is regular arrangement of atoms like a dots in Rangoli. So in case of regular arrangement of atoms, then obviously there is a fixed interplanar spacings. So that is one of the major criteria to satisfy the Bragg's law. That is why obviously crystalline materials exhibit the diffraction pattern. X-ray, once the X-rays are passed through the crystalline materials, there is a possibility to record the X-ray diffraction with variable intensities and the favorable positions and unfavorable positions. Favorable positions will give the maxima intensity and unfavorable positions will give the minima. So then obviously there is a possibility to understand the maxima and minimas in diffraction pattern that is useful to decide whether it is a crystalline or amorphous. Because in case of amorphous zigzag motion there is no interplanar spacing fixed value. So because of that in case of amorphous material there is no X-ray diffraction pattern is possible. So see here, this one is related to the crystalline material XRD and another is related to the amorphous material XRD. So by using this kind of pattern there is a possibility to differentiate the crystalline and amorphous materials by using the X-ray diffraction. And coming to the another thing, if it is a crystalline materials, what phase it is, whether it is a cubic phase or the tetragonal, orthorhombic or the monoclinic, or how the atoms are distributed, in which space group it is exist. We have different 7 crystal systems and 14 Bravais lattices, right, for crystalline materials. So what relate to this? So then obviously just remember the fingerprint, whatever the thumb impression is unique for every person, right? Similarly, the X-ray diffraction pattern for a particular material is unique. It won't match with the other kind of material. So based on this, by comparing with the standard diffraction data, there is a possibility to understand whether it is a cubic material or the tetragonal material, orthorhombic, and which space group it is. Everything can be measurable. First one, crystalline and amorphous can be decided, and in addition to the crystalline there is a possibility to understand which space group it is, which phase it is, based on the peak positions, where the peak is exist in that particular XRD pattern. Just I discussed the thumb impression is unique for a human being. Similarly, X-ray diffraction pattern is unique for single material. Based on this statement, there is a possibility to understand whether the impurity elements are present or not in that particular material. For example, like a well-known example, I just take it as the gold is a one metal. I just taken the XRD pattern and it is observed like some values. That means for some particular angle there is a possibility to get more intensity, and for other it is giving minima. So if the copper is added, then obviously some impurity element is added to the pure gold, right? When you are getting the XRD pattern of this material, then obviously copper is representing the another additional peaks in the XRD pattern. That information is used to understand what kind of impurities are present, or what is the impurity percentage in the material. That is also possible to measure by using the X-ray diffraction technique. So one, crystalline or amorphous, and then which material it is, or whether it is a cubic phase, or what is the phase and what is the space group, and what are the elements present, impurity phases are exist in that particular material or not. If the impurity is present, what is the percentage of the additional impurity is occur in addition to the original phase. That is also possible to measure by using the X-ray diffraction technique. So this X-ray diffraction technique is one of the most important, especially for the structural characterization for a particular material. So it's not give the morphology, like what kind of shape of the particle, what is the nature of this particular shape point of view, and what is the exact size. This is not possible to get the exact information related to the morphology, but there is a possibility to understand the structural information like lattice parameters, angles, strain values, how the atoms are distributed in a particular material. Everything can be possible by using the X-ray diffraction data. And in addition, the peak area. So for example, if it is normal and it is going up and it reached to the maximum and then going down. So the peak broadness, that called as the broadness of the peak. So in terms of like a FWHM, generally we represent it as full width of maximum, that is intensity high to the half of the intensity, full width of maximum. So that particular parameter is used to understand what is the crystallite size of the material. Generally, the crystallite size is used to measure by using the Devier-Schermer formula, D equals to 0.9 into lambda by beta cos theta. Here the beta is the full width of maxima that we discussed just now, relate to the peak broadness. So that is used to measure the crystallite size. The same is used to measure the strain. So for example, if just see here, the broadness is more for the low crystallite size and the broadness is low for the high crystallite size. So based on the peak broadness, there is a possibility to understand whether the crystallite size is low or high. That is also possible to measure. And another parameter, the intensity. If the intensity is more, the peak intensity or sharp and it is more, then we can say that it having more crystallinity compared to the low intense peak positions. So structural characterization relate to the whether it is a crystalline or amorphous is the first one. The second one, if it is crystalline, what is the space group, what is the phase, there is a possibility to measure. This is the second one. What about the third one? Impurity element percentage can be measurable. The fourth one, crystallite size can be measurable by using the full width of maxima values using Devier-Schermer formula. So in addition to all these information, there is also a possibility to understand how much crystallinity present in the material. So this is about the complete information related to the particular material by using the X-ray diffraction data. Generally, X-ray diffraction data is obtained by by passing the X-rays through the material. So the reflected X-rays, the scattered X-rays are taken, the reflected electrons of the scattered X-rays are taken and collected, and the data is given in the form of diffraction once it is matched the condition like Bragg's law, that is 2d sin theta equals to n lambda. So the major disadvantage is it won't give the morphological information, it gives the complete information related to the structural characterization. That it meant by XRD is used for the structural characterization of the material but not for the morphological characterization of the material. I hope it's clear. So we'll meet with another video. Thank you. If you like, or if you any point of time, if you feel the video is useful to you, please try to subscribe the channel and recommend the channel to whoever required. Thank you.